Welcome to Big Questions Talk Series by Singapore Malayalee Association. My name is Shraddha, and I'm the Assistant Secretary for the Singapore Malayalee Association. Am I audible?
Yes, we can hear you.
All right, sure. Okay. So this is a new initiative started by the SMA Tech Forum. This is our first event. The objective of this series is basically to introduce interesting subjects to the wider audience and to provide a platform for tech enthusiasts to share their knowledge and research, to engage in meaningful discussions, and to collaborate with each other on various projects. We also hope in the future to be able to organize events like workshops, training sessions, hackathons, and others. So how are we going to achieve these objectives? We're going to be conducting a series of expository talks on a variety of subjects. And these talks are not meant to be, like lectures that you attend in school, but something a little bit more engaging and out of the ordinary. And we hope that it'll be informative for many of you. The focus will be on cutting-edge technology and innovations. So if any of you are interested in being speakers for this series, or if you have any ideas, suggestions, or questions, feel free to reach out to us at techforum@malayali.org.sg. And for updates on future sessions, you can find them on our Facebook page. Right. So maybe let's move on to introduce the speaker for today. Right. Robin Vinod, as you can see, he's a JC2 student at NJC with some interest in machine learning and app development. So let's hear from Robin himself. So Robin, what got you interested in programming?
Hi, everyone. My name is Robin. I hope all of you can hear me.
Yep.
So I first started programming when I was in secondary 2, and what really got me interested in programming was an opportunity given to me by my secondary school to go overseas when I got to Sec 3 if I built an application that somehow contributed to the student community. So I was really interested and wanted to go on this trip. So that's how I really started to learn programming.
So Robin, you started at a very young age. Could you tell us more about what kind of programming you've done and what has been the impact of it? So, the stuff that you've built, has it been used by anyone?
So to get the opportunity to go on this trip, I built an application that helped student counselors in my secondary school mark students as late because this was one of the duties that a student counselor had to do. And it was really a manual and labor-intensive process, which I wanted to automate using an iOS application. So I really started off just building applications for the school community. And recently, I've started being interested in machine learning and artificial intelligence, so which is kind of why I'm giving this talk today.
Okay, so what kind of programming are you interested in?
So mostly, I'm interested in mobile application development and machine learning research. So I like applying my knowledge to build applications that help other people. So some of the applications that I built for my secondary school are still being used today. And some of my research also has been published to conferences as well.
That's cool. I mean, it's always good to see that your work, other than having impact in academia, it's actually having practical impact, and that the student counselors have reduced workload from, not having to do any mundane tasks now. Right. So thanks, Robin. So before we begin, just some quick housekeeping matters. So we'll let Robin finish his session, and we're going to keep all question and answer sessions till the end. So meanwhile, if any of you have any questions, you may type them in the chat box, and Robin will address them at the end. Also, we hope everyone can please mute your mics until the end when it's the Q&A session. Does anyone have any questions at this point? You can raise your hand, you can type in the chat window, or you can speak. All right, there don't seem to be any questions. In that case, we're going to start the session. So over to you, Robin.
Okay, thank you, Shraddha. So let's get started. Today I'll be talking to you about demystifying artificial intelligence and how intelligent machines will change the future. So, artificial intelligence, or AI, is a term that gets thrown around a lot these days. A lot of people see it as the next big thing in computing, and pretty much every tech company has a team dedicated to incorporating AI into their products. It's reached a point where you can find a new news article each week talking about how AI has made another big breakthrough. And you can pretty much put the name of any industry into this blank, and this statement will still be true. Even today, when the technology is still pretty new, AI has been used effectively in a lot of things that we use daily. One example of this is the Google Assistant or Alexa, which is something a lot of people use on a day-to-day basis. AI is used to decipher and understand natural language, and is also used to make the assistant's voice sound more natural. Finance is another industry where AI is already being used. Many banks are starting to perform risk assessment and fraud detection by getting AI to analyze a customer's details. AI algorithms are also being used for high-frequency trading on the stock market. And another example of where AI is being used now is this piece of news I'm sure a lot of us have heard before, where last year Google's AlphaGo AI was able to beat the human Go champion. Go is considered one of the most complex board games in the world, and unlike chess, it's not a game that can be solved using classical computers. In fact, the champion retired shortly after losing this match because he said that the AI's play was perfect. So as you can see here, AI is being used in a lot of new and interesting industries that a lot of us may be aware of right now. But in a lot of ways, AI is still a concept that is misunderstood by a lot of people. So today, we're going to talk about what exactly is AI, how it works, the things it can and cannot do, and what will happen in the future when AI has matured. So let's get started. So what exactly is AI? It is a process of getting machines to think like humans, to solve a task that typically requires human intelligence. This task can be anything. It can be something simple like prediction, classification, segmentation, or something even more complex like driving a car or translating a sentence. But this makes you think, what exactly does it mean by human intelligence? To me, human intelligence is the ability to reason, solve problems, learn, make decisions, and generally just refers to skills that are more than just following instructions. So what we are trying to do in artificial intelligence is give machines some of these capabilities to help it solve a task. Now this is different from a classical computer, which works based on algorithms that you code. An algorithm is just a simple set of instructions, sort of like a flowchart. Since the computer is just following instructions in your code, there's no learning or advanced reasoning going on. If you coded it, the computer can do it. If you didn't, the computer can't do it. It's just as simple as that. This is different in AI, where a lot of times there's no fixed set of instructions, but rather the computer learns what to do on its own. So now we have to get to how exactly does an AI learn to learn on its own. To understand this, we need to talk about machine learning and deep learning. AI, ML, and DL are terms that we hear often when we talk about artificial intelligence. And a lot of times these are used interchangeably. So let's clarify what they actually mean. As mentioned earlier, AI is a technique that allows machines to mimic human intelligence. Machine learning is just a simple subset of AI, where we use statistical methods to allow machines to learn from historical data. And deep learning is just an extension of machine learning, where it's a more powerful version of machine learning. So to understand, in simple terms, machine learning and deep learning is just a process through which we can achieve artificial intelligence. So to understand how AI works, we have to look at machine learning. Machine learning is a statistical method that allows computers to learn from historical data. At the most basic level, machine learning lets us to do two things: classification and regression. Now, classification is pretty straightforward. It's about finding a line or a plane that separates two or more clusters of data. Depending on which side of the line the point lies on, we can classify it into two or more groups. So let me give you an example of this. Let's say that we want to classify a picture of a cat and a dog. We can convert the image to a mathematical vector and plot it out. And it will look a lot like the first graph that you're seeing there, where a lot of the points overlap and there's no clear clusters or distinction that we can see. What machine learning allows us to do is by using statistical methods, we can manipulate these vectors and start to form clusters with these data. Now, once we have a clear separation of these points, as you can see in the last graph, we can start to draw a line or a plane that allows us to classify between a cat and a dog. So these statistical methods that I'm talking about is just simple mathematical tricks like standardization or principal component analysis that allows us to form these clusters. The other type of problem that machine learning allows us to solve is regression. Now, regression can be a little difficult to understand, so I'll give you a very basic example of it. Regression is just fitting data to a mathematical function to predict a value. So let me give you an example. Let's say that I want to predict the height of a child given his or her age in months. So I go around and I do a survey and I get a historical set of data about children's height and their age. So using this data, I can plot a graph that looks something like this. Now the problem with this is that, as you can see, there's a lot of missing points in between. If I wanted to find the height of a child that's 24.7 months old, I don't have a data point there, which means I can't do it. So we can solve this by plotting a line of best fit around these points, such that the line describes the overall trend of this data. And now that I have this line, I can easily find the height of a child that's 24.7 months old, because that point lies on the line. So this is what regression is. We're trying to find this line that describes this whole set of data. So in this scenario, the mathematical function that I'm fitting the data to is the function of a straight line. So for those of you who are still in school, I'm sure you recognize this equation. This equation is for a straight line. So in this process called linear regression, we have this equation y equal to mx plus c, where y is the height and x is the age in months. So because we took a survey, we have historical data of y and x. Using regression, we can find the best values of m and c. So for those of you who know this equation, you know that m is a gradient and c is a y-intercept. And these are the two values that control the slope and the position of the line. So let's say we have a random line like this. By controlling the values of m and c, we can rotate this line and shift it to suit our data. So regression allows us to find the best values of m and c. Now, how exactly does this work? To find the best values of m and c, we need something that's called the loss function. Now, what the loss function allows us to do is see how wrong our guess was. So let's say that this red line is the best line that we want to achieve. That's our end goal. And the black line here is our first guess on what the line could be. The loss function would tell us how wrong our guess was. So in this case, we use something called mean squared error, which shows us how far our line lies away from the red line. So mean squared error, again, is just a simple statistical method that allows us to tell how wrong our guess was. So the objective then becomes to make this mean squared error as small as possible. Because by making this loss function smaller, the black line becomes closer and closer to the red line, as you can see here. So in machine learning, when we're doing regression, we start from a random value of m and c, and we make a small change to this value. If the change reduces a loss function, we can keep the change. Otherwise, we try a different change. So by making changes in the right direction, we can make this loss function smaller and get to the line that we want to see. So in the simplest of terms, regression is basically just a smart form of trial and error. And the reason this works well is because computers can guess and check really, really fast. Now, obviously, this is a bit of an oversimplification. There's a lot of math that goes into making this as efficient as possible. But in the end, it does boil down to just a simple form of trial and error. So just a quick summary up till this point. Machine learning is the statistical method through which we can learn complex data, complex patterns in between data. And the powerful thing about this is that we can visualize, we can find patterns in between data on data that has very high level of dimensionality. So for us, we can see up to 3 dimensions, but because machine learning is just dealing with numbers, it can take on any number of dimensions, some of which are more than 20. So the examples I've shown here is rather trivial, but in reality, we can find much more complex functions, ones with many dimensions we can't even plot on a graph. So we've seen machine learning's ability to classify and predict. it's not always clear how being able to do classification and regression translates into doing a complex task like driving a car. So one of the biggest strategies we use in AI is decomposition, where we break down a big problem like driving a car into smaller problems. And these smaller problems can be solved by using classification or regression. So let me give you an example of this. This is a video of what a self-driving car sees when it's driving around. So this is a self-driving car made by NVIDIA. Yeah, the video may be a little choppy because of Zoom, but it's just a video of what the car's camera see when it's driving around. Now, if I extract a snapshot of this video, you can see that all that is really happening is just a simple form of classification. The camera captures an image of the road, and pedestrians, the road, and other cars are classified into red, green, and blue. So using this technique of decomposition, we can break down a big problem into something that can be solved by classification and regression. So we can take a big problem like driving a car and break it down into smaller parts. So one of them is classifying objects on the road. So we need to be able to classify objects on the road to cars, people, and signs. And within these classifications, we can further break it down. So for cars, we can classify it into buses and trucks. And for signs, we can further break it down into stop signs or exit signs. Now, another thing we need to be able to do is predict the outcome of a decision. So this is where regression comes in. The computer needs to be able to tell what will happen if I change lanes now or if I overtake now. So as you can see, a self-driving AI is just a combination of smaller AI networks that specialize in one small subtask. And with each of them working together, you can solve a complex task like driving a car. Now, this process of decomposition works a lot better than you would think, because we have successfully applied this technique to many, many areas. And almost any problem that you can think of can be decomposed into smaller scenarios. So now I'm going to show you some examples of how AI is being used in various industries, some of which may not even seem like an area where AI can be used. So one of them is autopilot on planes. The autopilot on planes is usually based on fixed equations that describe the aerodynamic properties of a plane. So the autopilot is only capable of operating within the fixed parameters decided by engineers. But now, there's a lot of research being done to use AI for autopilot instead, such that the autopilot is able to function even in scenarios that are not accounted for previously. And although this tech is not ready to be used yet, there have been really good simulation results on work done by NASA. And one day in the future, we may even have an artificial intelligent plane that is completely capable of taking off and landing on its own. Another industry that AI is being used in is teaching, which is something that we don't really expect computers to be able to do. Recently, some Chinese schools tried an AI grader on student essays, and this grader was able to mark student essays with almost equivalent performance to a real-life teacher. Another profession that AI is being used in is doctors. Google's DeepMind was recently able to beat doctors in detecting breast cancer, and it was even on par when combined against two doctors, such that the AI was able to beat the accuracy of prediction against two doctors. And another industry where AI is being used is SpaceX and space exploration. So pretty recently, there was an ISS mission by SpaceX. Some of you may have seen the launch. The auto landing feature of the booster is based on AI, and the machine learning is able to calculate the trajectory to within 99% accuracy during landing. Drug research is another field where AI is being increasingly used. We can simulate protein interactions through AI, such that we can partially replace animal testing during the research phase. And pretty recently, an AI came up with a new antibiotic that can kill superbugs, the ones that are resistant to our usual antibiotics. As you can see, there's a lot of practical applications of AI. And the one I'm going to talk about now is actually something that someone I know worked on, where they used AI drones to detect diseases in plants and spray pesticides on only those plants to prevent overuse of pesticides. So it's basically a drone that flies around and it's got a camera on it, and it can tell which plants have diseases on them and just spray pesticides on only those plants. So as you can see, AI has the potential to revolutionize almost every single industry. And with billions of dollars being spent on research, it will only get better with time. Now, some of you might be curious to what AI research looks like. So last year, I did an internship with A-Star, where I was working on segmenting strokes from CT scans using deep learning. So strokes come in two forms, ischemic and hemorrhagic. Ischemic is when there's a blood clot and the brain is deprived of oxygen. So this shows up as a slight discoloration on the CT scan, as you can see in the red circle. It might be a little difficult to tell from the slide. And the other type is hemorrhagic, when there's a bleed into the brain. And this is a little easier to spot because it shows up as a bright, hyperintense region. The problem with stroke segmentation is that the changes in color can be extremely subtle, which means you need highly experienced radiologists. And in countries like the UK, there's a severe shortage of radiologists, and they don't work 24/7 in the A&E centers. Considering that a lot of strokes happen in the middle of the night, there's a huge possibility of diagnostic delays occurring. And this is a big problem in strokes because 1.6 million brain cells die every minute. And the chance of disability increases greatly every minute. And the treatments for the different types of strokes is also contradictory. Since one is a clot and the other is a bleed, the blood clot, the blood thinners that you use to treat a blood clot will directly make a hemorrhagic stroke worse. So you have to be really sure of your diagnosis before getting started. So there are some general deep learning algorithms that have been researched over the years that can already segment regions in an image. But there are some unique characteristics of a stroke, such as the shape and size variability, which is unique to this problem. And this means that the general deep learning algorithms don't work well for this task. So a lot of times, AI research is just building upon a general algorithm to make it suitable for your task. And this is where the complicated math comes in, and we try to manipulate these vectors to make it suitable for us. A lot of these times, these concepts are very abstract, since they deal with vector representations of an image in dimensions that we can't even visualize. So in the end, we were able to make an AI that could segment strokes with around 80% accuracy, which was 27% higher than the previous standard. Now, obviously, this is not good enough to replace a doctor, but it can provide satisfactory results most of the time, which means you only need a doctor for those very small percentage of edge cases. And the best thing about it was that the AI was just able to give you an answer in just 3 seconds, compared to the many minutes or hours that it takes a doctor. So most of the time, it will just take 3 seconds for a diagnosis. But even if the AI was wrong, you only wasted 3 seconds. So the cost to benefit ratio is really, really good here. Now, after seeing a lot of the examples here, it's pretty scary to think that AI is beating even highly trained professionals like doctors. And on top of this, there are people like Elon Musk who conjecture that there's a possibility that the AI will take over the earth once they become more intelligent than us. And this kind of reminds you of Skynet from Terminator, right? Where there's going to be a big robot uprising once AI is officially smarter than us. But is this really going to happen? Probably not. As powerful as AI is becoming, there's still a lot of things it cannot do. So an example of one of these is the Turing test. The Turing test was proposed by Alan Turing in the 1950s, and it's just a conversation between a computer and a human. If the human can't tell that he's talking to a computer, the Turing test is passed. Even 70 years later, we still don't have an AI that is capable of reliably and consistently passing the test. Something as simple as holding a natural conversation, which is something a child can do, is still out of the reach of AI. And another example of this is CAPTCHAs. I'm sure all of us have seen this at some point, where CAPTCHAs is used to detect bots from humans. And this is still widely used today because even though AI is capable of really good image recognition, it still struggles in the types of pictures that we see in CAPTCHAs. Ones where the image is partially obstructed or of really low resolution. So there's still a lot of ground to cover before AI is able to reach a level where they're able to replace us. Because by design, They don't work well in novel situations where they encounter something they haven't seen before, which is something as humans we do many, many times a day. Another weakness of AI is acquiring data to train an AI on. So we often need thousands of examples of data to train an AI. It's also really hard to make sure that the data is consistent. So for example, in medical imaging, the CT scans taken can be from many different machines, from many different countries, with many different settings, and with people of all sorts of different ages. So if you want to collect data, you have to make sure that it is consistent, such that the AI can work well. But it is really, really difficult to get a large set of consistent data. And we also have to make sure that the data we get is bias-free. Any bias in the data that we use for the AI will be passed along onto the AI as well. So for applications such as law enforcement, it's really important that we need to be able to remove all the bias from the data, which is not a simple thing to do. So as you can see, you can't just apply AI to any industry that you want. You have to do a lot of background work and preparation to make AI suitable for that task. And in a lot of industries, this is still many years away. That said, although AI has its limitations, jobs that are data-centric and repetitive will inevitably be replaced by AI. Although this doesn't mean that you'll lose your job to a robot, just that a small part of your job may be taken over by a robot. So here's an example of this. There's an AI being developed that looks through historical data of criminal cases and analyzes the verdict of other judges in the past. This is something that a lawyer usually does, but something that AI has the ability to do really well. But this doesn't mean that we don't need lawyers anymore, just that a small part of their job is going to be replaced. And an AI won't be able to represent you in court anytime soon. However, here's a list of jobs that are most likely to be fully replaced. And you can see that these are the types of jobs that are heavily reliant on data entry and repetitive analysis. So take careers, for example. I'm sure all of you have read in the news that Amazon is researching AI drones that can deliver packages completely on its own. And once it's functional, we don't need careers anymore. And this is similar to receptionists, where on a lot of websites, you can see chatbots and other things where you can ask it questions and it can pretty much tell you everything that you need to know. So in a lot of ways, AI is really powerful, but it still has its limitations. And at this point, I've pretty much covered all the main key points of AI that I wanted to cover. And in the end, AI is a sector that is growing really, really rapidly. And it will inevitably become a big part of our lives, whether we realize it or not. And I think that this quote by Max Tegmark, an MIT professor, is a good one to end off on, because it pretty much sums up the role that AI is going to play in the future. He says that everything we love about civilization is a product of intelligence. So amplifying our human intelligence with artificial intelligence has the potential of helping our civilization flourish like never before, as long as we manage to keep technology beneficial. So I hope that I've been able to cover the key points that I talked about just now. What exactly is AI, the basics of how it works, and some of the techniques that we use to incorporate AI into our daily lives. And for the purposes of this talk, I haven't gone really technical or deep into how AI works, because there's still a brief introduction on what exactly is AI and the things that it can do. So I guess now we've come to the question and answer section, where you can ask me anything about anything you want to learn more about AI, like how it's coded or how I can start learning, or what are some examples of AI architectures. So I guess Shraddha will be facilitating this session.
If anyone has any questions, please feel free to unmute yourself, or you can type your questions in the chat window as well. Okay, Robin, we have a question from Arun. He says, is the risk of AI or Skynet too high to develop AI? Seems even Stephen Hawking and Elon Musk are worried.
Okay, thank you for the question, Arun. So I think that the risk of Skynet is not too high. People like Elon Musk and Stephen Hawking are worried, and they're right to be worried, because As I've shown you, there's a very big potential of AI to completely disrupt the way we're doing things. But we're also the ones that are creating it. And while creating it, we have the opportunity to make it work the way we want it to. So like I mentioned previously, when we give data to train an AI on, we have to be really careful in making sure that this data does not contain any biases. So for example, some of the law enforcement facial recognition software that was being developed had this bias where a lot of the data it was trained on was on images of people with fair skin tones. And it was unable to work well on people with different skin colors. So a lot of the problems with AI is ones that we put there. So if we are not careful in making sure that the AI that we develop falls within our worldview or our goals, it can get out of hand. But I guess to directly answer your question, Skynet is definitely a few hundred years away. And right now, we don't really have to worry about that being a possibility, at least not in our lifetimes. But the thing we have to make sure now is coming up with a set of standards that we have to make AI researchers follow. So things like drug trials or human gene modification, there are a lot of ethical questions that come up that we still don't have a strong regulatory body or good regulations to follow. So I guess we do have to make some of these regulations to make researchers follow a strict set of guidelines so we don't have the possibility of AI getting out of hand. Yeah, so I hope that answers your question.
Yep. Next question we have from Sparsh Vashisht. Hi, Robin. Is it possible to make AI creative? Like, will they be able to come up with new ideas on their own without any human input?
Okay, that's a really good question and one that I'm still learning about. So for recently, we've been researchers have been working on something called generative adversarial networks, or GAN for short. So the whole point of a GAN is to make something new. So all other forms of deep learning networks are learning from historical data, which means that everything they are able to create is a subset of data that they have seen in the past. So if you ask it something to make something new, it can't do it because it is not part of the historical data. But this new form of network called GANs, they analyze patterns on historical data and try to generate new ones. So some of the things it's working on right now is image generation. So if you give it pictures of horses and zebras and all sorts of animals, what it does is it looks at the patterns that makes each of those items unique. And it tries to combine these patterns to create something new. So one of the pictures that Google released in their GAN was a combination of a zebra and a horse. So it looks like a horse, but it's got stripes of the zebra and it's a completely different color. So this is not something that's completely new. It's still learning from examples that we're given it. It's just that it's analyzing those patterns and combining them to make a new, interesting pattern that we haven't seen before. So I guess this is what we mean by creativity. But then again, in a lot of ways, it's still not the same level of creativity that we are talking about, where you can just start from a blank page and create something that's completely new. We still don't have that ability yet. And there's also creativity going on in AI for music. So some people have been working on generating new pieces of music that we haven't heard before using AI. So I guess this is the maximum level of creativity that we'll reach sometime soon.
All right. The next question we have comes from Neha. As an amateur in coding with a 2-year experience, which languages do you think are the most suitable in working with AI and image recognition?
So the two most common languages for data science is Python and R. So R is a language that's specifically made for data scientists, and it's not actually a language that I'm really familiar with, but a lot of people do learn it. But for me, I have experience in school learning Python, so I found it easier to get in and start on Python. So there's a lot of frameworks, open source ones that are built by Google and other people, such as TensorFlow and PyTorch, that work natively in Python. So they follow the same Python standard of simplicity and abstractness. So if you were to learn AI and deep learning, I think I would recommend that you start off with Python and learn PyTorch, because that's the most user-friendly and beginner-friendly language for AI. Yep.
Okay, the next one is a very interesting question. I guess this is a little bit more on the ethics part of it. This comes from Wang Portal. In the limitations of AI, you mentioned about the Turing test. However, in Google I/O, they have they have demonstrated how AI is able to directly call shops to make appointments. I think the one that was about making an appointment with a hair salon. So the humans on the other end had no idea that they were speaking to a bot. So what are your views on this? Should the bot be indicated as a bot, or should we allow the humans to not know that they're speaking to a bot?
Okay, this is a bit of a difficult question, I guess. But so in the context of the Turing test, the conversation that's going on between a human and a computer doesn't have a fixed topic. So the example that he mentioned in Google I/O, where the AI called the shop and made an appointment, and the person on the other end didn't know that they were talking to a bot. This is in the context of just making appointments to a shop. So it's a very fixed and closed off environment where there's not a lot of room for unpredictableness. But in the Turing test, it covers a wide variety of different topics. And while we can make an AI that's very specific and can do things like making appointments, it's much more difficult to make an AI that's general, that can just talk to you about the meaning of life, for example. And this is a scenario where computers don't work that well, and then they start failing the Turing test. So I think, if I remember correctly, the best algorithm that we have now is only able to pass the Turing test 30% of the time. And with regards to the view on ethics, I do think that the bot should be indicated as a bot, because there's really no downside to telling the person on the other side that they are talking to a bot, as long as the appointment gets made, I guess. And in a similar vein, there have been lots of news about things like deepfakes, where they start faking videos of people like Donald Trump saying some things. And if we don't specifically say that this was made by an artificial intelligent bot, it starts creating problems where it creates problems between people and can like incite social unrest. So I really do think that we need some regulations to make AI a safe technology.
All right. Next question comes from Chitra. I've read that AI is being used in COVID, in this COVID situation in some ways. Could you elaborate some ways in which it's being used?
Okay, so I think this is one of the things that I can speak to about, because recently there was a hackathon done by NASA where they released a huge number of data sets open to the public, and we could use this to try and solve any problem encountered by COVID. So one of the things I was working on is trying to predict COVID numbers 14 days later. So the number of daily cases that happens 2 weeks later. So the data that we had access to was mobility data from Apple and Google. So because Apple and Google, they have access to location data from our phones and Google Maps, for example, they can tell how much activity is being increased or decreased on a given day. And together with satellite data from NASA that measures nitrogen dioxide levels, which is a proxy indicator for human activity. So nitrogen dioxide increases when there are more cars driving around and there's more people out and about. So using a combination of all these data, we try to predict the daily number of cases 14 days later. So if there's a pickup in mobility and a pickup in nitrogen dioxide today, can we sort of say that in 2 weeks' time, the daily cases will increase, and in a way that hospitals will find useful? But in a lot of ways, it didn't work well because of the fact that there's a lot of variables going on. So especially in the US, the testing rates are very unstable and unpredictable. Each state has different testing rates, and each state report their testing numbers differently. So because there's a large inconsistency in the data that's available, it's very difficult to make any valuable contribution to COVID. And this is like the first pandemic that we had where we had access to technology like AI. So there's still a lot of unknowns that people are still trying to figure out. And I guess the most useful thing that AI can do is testing vaccines. So like I mentioned earlier, we can simulate protein interactions and test out vaccines before human trials. So I guess that's the strongest use of AI in COVID.
Right.
I hope that answers your question.
Yep. Thanks, Robin. Next question we have from a very young participant. He's in primary 5 right now, and he's asking where or how can he begin to learn AI?
There's a lot of free courses out there that let you learn AI, but at the age of P5, it's a little difficult to start because a lot of the concepts that we're talking about is things that I just learned this year in JC. So for linear regression, the equations that we're talking about, a lot of these are advanced mathematical concepts of calculus that we only learn later on. So if you really want to start learning AI, it's a bit difficult at that age, and I would recommend you just start learning programming in general rather than trying to specialize in AI. Because the problem with AI is that you really need a strong understanding of what you're trying to do. Because if you don't understand what's going on, there'll be a lot of questions that you have that you can't answer easily. Because when you're talking about AI, it's a lot of abstract concepts. You can't just type into Google. So unless you are proficient in the level of math that you need to understand it, it's a bit difficult. So I guess my advice is just start off in programming in general. And then once you get to secondary school and you start learning a bit of calculus, is when you can really start learning AI.
All right. Next question, Robin, we have from Rajiv. So what kind of laws and regulations are there currently around the development and use of AI?
So right now, like I mentioned, there's almost no laws, especially in Singapore, about the use of AI. So the laws that we have now are usually relating to the data that we develop AI on. So a lot of hospitals, when I worked at A-Star, we talk to hospitals, and they are the ones that give us data to perform AI on. So I guess that a lot of the laws right now relate to how hospitals acquire data and how they ask for permission and anonymity in this data that we use later on. But specifically when it comes to using AI, as far as I know, there's really no law on that controls how you are able to use AI.
All right. So I'm not sure if this falls within your area of expertise. We've got a question from Aruna. She asks rather, how soon do we expect therapy of diseases using gene therapy without use of drugs? Because drug development is a long process.
Um, I don't think that we can expect this anytime soon, because when you talk about drugs, right, there's a lot of things that you have to keep in mind. So each drug could have millions or billions of possible interactions that you can have in your protein chains. So this is one of the things I was working on last year, where we tried to detect gene modifications using machine learning. And we really realized quite quickly that there's so many possibilities of the ways that drugs react in our bodies that we can't easily simulate all of them, even if you have really big computers. So for the training of simulating drug data, we had to use the national supercomputer, and it's a multi-million-dollar computer, and as powerful as it was, it still barely could iterate past a few million iterations of a chemical compound. So when it comes to predicting gene therapy and how a modification in our gene will be affected, it's still really far away because the efficiency is just not there yet. But right now, we're still brute forcing new drugs. So like I mentioned earlier, an AI was able to come up with a new antibiotic just simply by brute forcing a lot of chemical compounds and see which one worked. But when it comes to complex drugs and gene modification, it's not something that's close to us right now.
All right. We have another question from Wang Potao. In another one of the limitations, you mentioned about the lack of data to train AI models on, but there have been recent breakthroughs in simulation technology that can just as easily generate data that is close to the real world to allow for easy creation of massive data sets. So do you think that the simulation data is accurate enough for AIs to train on?
No, I don't think so, because data augmentation is what it's called. It's a pretty new branch of data. So in my case, when I was doing stroke data, it's very difficult to augment new data sets from existing data sets, because when it comes to a brain scan, there's a lot of complex structures in the brain that we just don't have the technology right now to create new data sets. But when it comes to other things like pictures of cats and dogs, obviously those are images that we have a wide variety of them. And using some data augmentation techniques and different AI algorithms, we can generate new data for us to train on. But like I said, it depends purely on the use case. And it might work well for some scenarios, and it won't work well for other scenarios. But I did try it out for my medical imaging one, and it didn't work at all, because it's just far too complex to create new data sets. Yep.
All right. I think the last question that we have here is, comes from Alok, and he's asking, Robin, interesting point you raised on separating AI and ML. What use case do you see in using AI without ML?
So the word AI is a really big branch of computing. So when we talk about AI, the one that we think about is really machine learning, and we use machine learning to achieve artificial intelligence. But there's also new forms of machine learning that's being developed, things like reinforcement learning, which don't really fall into the category of machine learning or deep learning. But in the end, a lot of what we're doing is still using historical data to try and solve a task. But reinforcement learning is a new technique, a pretty new technique, which is what they used to beat the champion at Go. So usually, for things like Go, they don't really have an access to data sets of Go games in the past that they can train on. So what they do is they get the computer to play itself. And as it keeps playing itself millions and millions of times, it learns patterns and things, which allows it to win when it plays in the future. So because it's in the form of a game, it's really quite different from machine learning. Because in machine learning, we are always trying to get closer to the best answer. But when you're playing a game, let's say chess, for example, you might be able to win the game in 5 moves if you sacrifice your queen now. But in typical machine learning algorithms, it can't do that. It can't sacrifice a queen now to win the game later on, because the way that loss functions work, sacrificing a queen will be seen as going in the wrong direction. So I guess, okay, I just saw your comment, and you would argue that RL is also a type of ML. I guess so. You could say that, but at this point in time, to achieve artificial intelligence, in my opinion, ML and DL is really the only way. And because AI is such a wide and topic, there may be a new method that we can discover in the future. But at this point in time, ML is really all we have, and deep learning, of course.
All right. I don't think we have any more questions. So thank you, Robin, for taking all the questions that we had. So at this point, I just want to go back to the first slide about the SMA Tech Forum. Robin?
Okay, hold on. Yeah, sorry, hold on.
It's okay.
Yep.
All right. So for those of you who joined late and missed this part, I just wanted to reiterate that this is the first session from of the Big Questions Talk Series organized by the Singapore Malayalee Association's Tech Forum. And this is a new interest group that aims to introduce interesting subjects such as today's artificial intelligence to the wider audience. So you can see we had a wide range of participants. I think the youngest one might have been, the student who's in primary 5. We also want to provide a platform for tech enthusiasts to share knowledge, to engage in discussion like we did in the Q&A session just now, and to collaborate on various projects. And we hope in the future to be able to organize events like workshops, training sessions, and so on. The focus will be on cutting edge technology and innovations. and we're going to achieve these objectives through a series of talks such as the one today by Robin. So if any of you are interested in being speakers, if you have any ideas, suggestions, or questions, please drop us a note at techforum@malayali.org.sg. Specifically, we hope this will be useful for students and young working adults. You'll have the opportunity to learn from the experience of other members, and you get to learn things that are not usually taught in school. You get exposed to industry trends, and hopefully this will make you a little bit more industry ready. Right, for any updates on future sessions, you can find them on the SMA Facebook page. At this point, I'd like to hand over to SMA President, Mr. Prem, to just say a few words.
Hi, hi, Robin and everyone. Robin, this was an excellent presentation. You articulated the subject very well, presented it extremely well. You are just 17, and I know you only for the last 17 years. I know you from the day you were born. And really stunning, the way you have handled it, the way you have answered questions, and the depth of your knowledge at 17. I do not know where you are heading to. All the very best, Robin, for whatever you're going to do in future. Absolutely, you have a great future, definitely.
Thank you.
Then I just wanted to have a couple of questions because Arav, the question Arav raised is very good point, because you started very young, and there are a lot of students who go to university and they university or poly or wherever they start learning, say even for coding, and they don't learn beyond the textbooks. So probably you might be able to give some suggestion, ideas, where to learn programming, where to start, and or your experience, how did you start learning programming? You said that particular competition for going to the SFO, right? I believe.
Yes.
Yeah, SFO. Yeah. That one triggered you. So and how did you start learning programming? Probably that Arav or someone else who is starting new may benefit.
Okay. So I think the biggest problem when it comes to learning programming is that it's really boring. There's a lot of great courses out there, free ones and paid ones on stuff like Coursera and YouTube that do a really great job of teaching you programming, but I just don't have the attention span for it, and I find it really boring. So the most important thing for me when I started learning was having a project that I could do on the side together with it. So in my case, was making the application for student counselors. And it was something that I found useful, and I knew that my friends would find useful as well. And it was only because of that project that I still had the motivation to actually spend my time and learn. And the thing is, if you don't learn with a project, you can't apply what you've learned, and you'll forget it really soon. So I guess my biggest advice is, if you're going to start learning programming, you should start with a project. It doesn't have to be a really big one, just something that you might find useful or people you know might find useful. And doing it as you learn will help you remember it much better and actually appreciate the thought process that goes into coding. And I guess in a way that you also have to be patient, because some of the courses are 40+ hours long, and if you're going to learn it together on top of school, it's going to take a lot of time, and you really need to find motivation within yourself to keep going and keep learning, and always make an effort to make sure that no matter where you are, a beginner or advanced, you're still understanding everything that you do and putting in as much effort as you can to make the best things that you can out of whatever skills that you have learned. Does that answer the question?
Yeah.
Or would you like to?
No, Robin. Yeah, that's good. So probably Arav, you can start from there. And what I wanted to say this, I mean, Shraddha has made that point twice. Anyway, but what we are trying to form is a community where people like Robin and there are some others like that who have started this. They started this journey early, probably, and they are or they were somewhere already in the profession. Some are very young professionals already started working on this industry. And we have students who are newbies. So in this community, it's a small community at this time, and what we are trying to do is but they can work together, they can interact, they can help each other, they can mentor. So there are some one who has got more experience is mentoring some newbies. So it is trying to learn from other people's experience. So that's what we are trying to do. We are trying to build a community. So if you think, if you are, or anyone who's listening, or somebody in the school like Ara, you would like to have some help and on the thing, from, for example, from Robin or someone else, please be in touch with us, and you can be the part of a community, and you can learn, and there'll be someone who has got some spare time will be able to mentor you in the process. So come on board. And those who have already done some projects like Robin has done it in machine learning, and there are people who have built, say, websites and all those things for a specific purpose. And if you'd like to share that, how you did it, because a lot of people who would like to learn how to create a simple website. So probably you could do a presentation, and that could be beneficial for some other people. So if you like to do some presentation, or if you have some ideas or something, please get in touch with us, and you can send it to the email address on that link. Or you can just send it to us. Our contacts are available on the SMA website. You can send it. You can contact us using any method, and definitely we'll be happy to support. And if you would like to hear about any specific topic, if you like this, I'm just repeating Shraddha's point just to stress it. Please let us know, and we'll try to find someone who can take that topic. That's all, Shraddha.
All right. Thank you, Premchetan.
Yeah,
the presentation will be shared with all registered participants soon, if you've registered through Wild Apricot. Okay, so we have another question from Alok. He's asking if anyone here is in the SG tech space. Is there a LinkedIn group?
I do not know, but that could be something which we can explore.
There probably is. I don't know if anyone else. Yeah. So we've got a response from Nandu. He says there's a very popular Telegram group called DevSG.
Oh.
Yeah. All right. If anybody wishes to say anything to Robin in person, otherwise there's a lot of comments, with positive reviews of Robin's talk. There's nothing else planned at this point, so I think we can go ahead and end the session. So thank you everyone for your time. And if you have any suggestions for topics, please get in touch with us. We look forward to meeting you in our next session.